Hello and welcome to Future-Proof Your Buildings mini masterclass by Aereco. Aereco, which is part of the Aldes Group, develops innovative ventilation solutions for residential and office buildings with a key concept: the modulation of airflow rates according to the needs. Several lines of products can be implemented in various systems, from natural and hybrid ventilation to DCV, MEV and MVHR. Aereco SAS, based in Paris, France, invented modern humidity-controlled ventilation and has been the market leader in demand-controlled ventilation for dwellings in Europe for over 40 years. Aereco Limited are the only Agrement-certified demand-controlled ventilation system to meet Irish Part F regulations. The Agrement applies to all our demand-controlled mechanical extract systems and provides a unique pathway for constant pressure systems to be validated under the NSAI scheme. So what is DCV?
In this video, we are going to look at demand control ventilation, or DCV. DCV, rather than being a specific system type, like the ones in the last video, is more a strategy of ventilating buildings that can be applied to many of them. So what is it then? Well, DCV is a way of ventilating buildings that looks at their air quality and controls the systems based on, well, demand. Let's explain. Every home, or room for that matter, will have a rising or falling need for ventilation. In a bedroom, you go to bed, you wake up and go to work. In a bathroom, you might shower in the morning then leave. Someone else might shower in the evening, brush their teeth and so on. In a kitchen, well, you get the idea. At a whole building level, people come and go, going about their daily lives. Every home is different, every day is different, and over the lifetime of a home, families grow and shrink. In the past, we had to pitch a guess at how much ventilation was needed. This might be on an average family. It might be on the performance of the house or its size. It's where we hear things like half an air change an hour or 8 litres a second. The trouble is, a guess is a guess. Ventilate too much and you might cause thermal discomfort, noise problems and waste energy. Ventilate too little and you might affect air quality, and as we pointed out in the first video, leaving the occupant to control it is not without its risks. This balancing act was one of the reasons MVHR has become popular, as a way of ventilating enough but doing so efficiently. But if you think about it, even MVHR without smart control is a bit like inventing an energy-efficient light bulb and insisting all the lights are left on. Demand control ventilation, or DCV, is a way of adjusting ventilation automatically according to demand, with sensors that measure air quality or need, in every room, in every dwelling, at any time. This approach is as logical as controlling your heating with a thermostat, and can be applied to many systems, from passive stack ventilation through mechanical extract systems to MVHR, in individual homes and collectively in multi-family buildings. So, as the occupants of a home wake and go about their day, come and go, cook, shower, rest and socialise, the system will react accordingly, ensuring that the right amount of clean air is delivered where it is needed, and when it is needed, securing good indoor air quality faster than a fixed system, and, when appropriate, the system will reduce the airflow and save energy. Is it new? Not really. Founded in the early 80s, when the hygroscopic nylon strip was patented by the first laboratory, and founded by Pierre Jardinier and the company. Aereco have been using DCV now for over 30 years, with many millions of systems installed all over the world. The humidity-sensitive strip is still used today, providing a reliable, accurate and robust way of measuring moisture and controlling ventilation. Did you know that almost everything we do in our homes that creates pollution has a link to moisture? If you think about it, from the obvious, such as the moisture present from cooking, cleaning, washing, drying, to the less obvious, such as the moisture or CO2 present in your every breath. By tracking moisture, we also effectively track the occupant, which means if other pollutants are present, like odours or VOCs for example, it's a great way of limiting our exposure to these as well. We can also help the system by using other sensors like a presence detector that can boost the system if we create odours, for example, in a toilet. The nylon strip reacts to moisture in the air by stretching and shrinking in a defined way, allowing us to control how open or closed the fresh air inlets are. It does this very accurately and consistently without the need for a power supply. The strip is very reliable and lasts a very long time. In fact, we are so confident in this that it has a 30-year guarantee. All of our systems connected to these grills are designed to react automatically, increasing and decreasing the flow of air through them. This means the system as a whole, whether it's passive stack ventilation, continuous mechanical extract ventilation, hybrid, or MVHR, provides consistently good indoor air quality and energy-efficient ventilation on demand.
The BXC-EG is part of the BXC product family and offers all the essential features of an extract vent. It provides multiple activation modes for the additional airflow, allowing ventilation to adapt to the occupant's needs through options such as presence detection, manual switch, or remote control. Its humidity-controlled technology automatically adjusts to the airflow based on moisture levels, ensuring optimal performance. The BXC-EC is a discrete, humidity-controlled extract unit that ensures efficient ventilation, adjusting in response to the room's humidity levels. To ensure optimum aesthetic and discretion, the new BXC-EC extract unit is installed within the wall or ceiling and covered with a cover plate that completely conceals the ventilation duct. This plate can be customised with paint to match the style of the room. The EHT2 is the new generation of humidity-sensitive wall air inlets. It can be installed on the wall using either 100mm or 125mm openings and serves as a great alternative to window air inlets, especially when there isn't enough space on the window. With the right accessories, the EHT2 offers excellent acoustic insulation, reducing noise by up to 52 decibels. This makes it one of the best performing products in its category. So what is ventilation?
Well, it's the movement of air into, through, and out of a building, and we can break it down into two principal types. There's unintended ventilation, well that's leaks to you and me, and intended ventilation. That's holes in the fabric of the building for the purpose of ventilation and fans, etc. Basically the stuff that moves air on purpose that, well, isn't leaks. In this video, System Types, we are going to look at 4 typical systems that provide ventilation. 1. Natural ventilation and intermittent fans. This is a series of holes in the fabric of the building, in walls or windows located in every room in the house. The idea is, we allow air to move into, through, and out of the house naturally because of the wind outside. This process is called cross-ventilation. In addition, fans in wet rooms like bathrooms and kitchens remove moisture at source. They're called intermittent fans because they're only on for a short period of time, when there's activity in those rooms, usually triggered by a light switch or something else. Once they stop, we rely on the cross-ventilation to manage the rest. Did you know? When you sit in a building with cross-ventilation, on one side you will feel cold air coming in, and on the other side you won't, because warm air is going out. This is what's supposed to happen. If you close a vent, you not only stop the process of ventilation in that room, you can also affect the other side too. If your fans aren't working properly, or you've turned them off, moisture that's supposed to be extracted can now be picked up by the cross-ventilation and find its way to other parts of the house, often condensing on cold surfaces, causing mould. 2. Passive stack ventilation, or PSV. Think of a chimney from a wet room in the building to the roof, and you have a passive stack. These replace extract fans and provide a natural low-energy way of extracting moisture at source. And, because it has no moving parts, it requires very little maintenance. As with natural ventilation, we have holes in each room to supply fresh air, except now, not in rooms where the stack is. Passive stacks work in a similar way to a normal flue for a fire, in that it creates a draw by a combination of suction from wind at the top of the flue and a temperature difference between the top and the bottom. This is called the stack effect. Did you know? Passive stacks, like fires, rely on wind and temperature difference to work. This means that even if designed correctly, due to wind and temperature changes outside, there are times when it will work better than others. Passive stacks also operate at very low pressures. This means that if you close vents or the stack is not designed and installed correctly, it can easily affect its ability to function properly. 3. Continuous mechanical extract ventilation, or MEV. With this system, we continuously extract from wet areas and supply air to dry areas through holes in walls or windows. Similar to passive stack, except this time we extract with fans. This can be done separately in each wet room. This is called decentralized MEV, or through a central fan, this is called centralized MEV. These are quiet and energy efficient fans. The idea is that a steady, reliable movement of air out of a building creates a steady and reliable flow in. Because of this, it can be a robust and reliable way of ventilating a wide range of buildings. Did you know? When commissioned, there is a requirement for a certain amount of air to be extracted from each type of wet room under building regulations. This should be checked again when the ventilation system is serviced. Time and resources should be set aside to set up and commission the system properly. 4. Mechanical ventilation with heat recovery, or MVHR. An MVHR system is typically a large centralized unit that both extracts from the wet areas and supplies fresh air to the rest of the building via a series of ducts. Because the system is designed to supply as much air as it takes out, it's called a balanced system. An MVHR system is designed to not only provide good indoor air quality, like the others, but it's also designed to recover heat that would otherwise be lost through ventilation. It does this by passing the stale warm air it is extracting past the cold fresh air it is supplying. This warms the incoming air up. It does this in a heat exchanger within the fan unit. As such, MVHR is often used in energy efficient buildings to assist in the retention of heat. Did you know? An MVHR system needs to be in an airtight house to really get the benefit of recovering heat. If too much heat is lost through leaks, then the energy benefits of the system are never realised. It also has a lot more going on inside than other systems, and as such requires a little more attention. For example, it has filters to protect both the heat recovery exchanger inside and also the condition of the ducts and air it's supplying. If these are not looked after, the system's performance will be affected, as will the air quality. Like an MEV system, an appropriate amount of time and resources need to be put aside to set up and commission the system properly. A final thought. Ventilation is an integral part of a building's success or failure. Whatever system you choose, what's important is that you understand the strengths and weaknesses of the different systems and have a plan for your building, whether it's new, a renovation, or you're trying to solve an existing problem.
So this is the Inspire Airside V2. The MVHR system is ideal for installation in false ceilings or attic spaces, making it perfect for both new builds and renovation projects. It delivers market-leading performance and air quality while offering the best size to weight balance. And here are some of your FAQs.